Hello, welcome to application number 3, my final presentation. In this presentation, we're going to talk about patients' HDL levels, aka their good cholesterol. Now first we're going to talk about the sample group and how we collected the sample group. We have our sample size of 300 patients. And we spoke to each state's most attended hospital in that month to select a patient from each race that has visited their facility in that last month, with the patient's permission, that being Caucasian, Black or African American, American Indian or Alaskan Native, Asian, Middle Eastern, and Hispanic. Now we have a couple of goals that we want to accomplish for this application problem. First is to find the sample mean. Second, standard deviation. Third, the probability of finding a patient with an HD level of less than 40 milligrams per deciliter. And then lastly, the probability of having a patient with a HD level more than 100 milligrams per deciliter, which both of those numbers can lead to a higher cardiovascular problems. Before we move on to our calculations, first let's take a look at our histogram. Our histogram has a current sample group of 300, broken up in bandwidths or class widths of 10. Now taking a little bit quick look at our histogram, you can kind of see that it's symmetric to a normal distribution, which it will definitely help us later on in our future calculations. Now let's go ahead and take a look at how to solve for mu and sigma, or in other words, the mean and standard deviation. Now first, at mean. How we found mean is that we take into account all the patient's tests, their HDL levels, we add them together, and that divides it by 300. 300 because that's how many patients we have, and it gives us the approximate of 53.66 milligrams per deciliter. And for our next calculation, we're going to look at standard deviation, or sigma. Now this right here formula is the formula that you would actually do if we're doing it by hand. But fortunately, I have the great use of technology. So I actually used Excel and entered equals standard deviation dot S. And then I selected all data points that I would wanted, which these data points were those tests of the patients, their HDL levels, which gave us a standard deviation of 15.438 milligrams per deciliter. So already we were able to go ahead and tackle two of our goals, which was the sample mean, which was mu, and the standard deviation, or sigma. Now let's go ahead and look at the probabilities. So the first probability we're going to look at is finding a patient whose level is less than 40 milligrams per deciliter. And then next, finally, we're going to get to the probability of having a patient with HD level of more than 100 milligrams per deciliter. So fortunately, we had the great use of Excel once again in these probabilities. So Excel did have a heavy hand in doing the calculations. However, we have to first determine if we can even use the calculations that I've displayed here, which is the normal distribution. And honestly, we already addressed that by addressing that our histogram is symmetric to that of a normal distribution standard histogram, or that normal curve. So for our first patient, which is less than 40 milligrams per deciliter, we were able to use equals norm.dist. We inputted the mean and the standard deviation, and that we wanted to put in the value of what we wanted to find, which was 40. And that gave us approximately 0.18807 chance, or approximately, in other words, 18.807% chance of finding a patient with a HDL level less than 40 milligrams per deciliter. Now, for our second patient probability, we actually can do something similar, but there is a slight difference because for our less than 40 milligrams probability, we actually were already looking at the left side of our distribution, our histogram. Now we're actually going to try to look on the right side. So what we do is we plug in again equals norm.dist, enter 100, which is the value that we're looking for, the mean, and standard deviation. Now that's for everything on the left side. So once we get that number, we will do 1 minus that number, which ultimately in the end gives us 0.00134 chance, or 0.134% chance, which is really, really low according to the patients that we have received. Now already we were able to tackle all 4 goals for this application problem. Finding the sample mean, the standard deviation, the probability of having a patient with the HD level less than 40 milligrams per deciliter, and then finally the probability of having a patient with HD level more than 100 milligrams per deciliter. Now what is our conclusion? We can actually conclude that the chance of having a patient with less than 40 milligrams per deciliter and having a patient more than 100 milligrams per deciliter are both low chances. So thankfully, the patient sample group that we have received all have a low chance of actually receiving any extra cardiovascular issues due to having good cholesterol levels.